Okay, this video is about assigning oxidation numbers to different elements and different compounds, or the elements in the compounds. Anyway, so the first thing, here's a big long set of rules right here, but it's just kind of with practice you'll get the hang of it. So rule number one, the oxidation number of anything, I like to say anything by itself or with itself, is 0. So like O2, the oxidation number is 0. Same thing for like I2, Br2, or even if you had like sodium metal, that would be 0. Anything by itself is 0. Okay? Now, when something is with something, that most likely means it's some sort of ion or something like that. So you got to end up using the charges of the ion. So for one thing, you know that fluoride is always -1. Now you can use that to your advantage because this manganese has to be some charge to offset 4 negative 1s. So to offset 4 negative 1s, we only got one manganese. It must be +4. So this manganese is +4 because it's a transition metal. They can have more than one possible charge. Okay, here's oxygen. Oxygen is always -2 when it's with something. There is one catch to that. Let's see where that's at. Okay, that's like rule 5. Okay, oxygen sometimes can be -1, and so it can be something like, you might see this a lot of times on the AP test, like hydrogen peroxide. So when oxygen is a peroxide, I think that's really the only one you need to really know. It's going to be -1. All right, and so I wouldn't really worry about it. Besides, normally it's -2, but when it's with a peroxide, it's -1. I think there's another one like sodium peroxide, Na2O2, and the oxygen is -1 there too. But anyway, all right, so oxygen's usually -2, unless it's a peroxide. So 3 times -2 makes a total of -6. Okay, so 2 times what has to make +6 because a compound's neutral. So this iron has to be +3. Okay, oxygen's always -2, hydrogen's always +1, or most always it is. Okay. All right. Anyway, so then here's kind of the whole thing. You can do this a couple different ways. I like to do it this way right here, like sulfate. I know sulfate, if I look at a polyatomic ion chart, that sulfate in total is -2. Okay, it's an ion, and there's 2 oxygens. 4 times a -2 makes a -8. So what must sulfur be to give you a net of -2? It has to be +6. Okay, or you can just do the whole compound together. 6 positives plus 2 positives are 8 positives, and 4 times a -2 is 8 negatives. So anyway, that's how you could do that. Let's try a few more here. All right, so let's just say you have a chemical equation and we're trying to assign oxidation numbers to everything. So iron's by itself, it's 0. Oxygen's by itself or with itself. This oxygen's -2. That makes this +3. 3 times a -2 is -6. Oops, -6. 2 times a +3 is +6. Okay, let's go down here. Okay, oxygen's -2. Nitrogen, let's hold off on that one for just a second. Silver is always +1 if you look that one up. Okay, so 3 times a -2 is -6. Okay, silver is +1. Okay, now we got to think about, well, what must nitrate be so we can have this -6 canceled out? It must be +5 because 5 plus 1 is +6. Or you can do nitrate like this. You know nitrate is -1. So there's oxygen is -2 for -6. What must nitrogen be to give you a net of -1? It has to be +5. Okay, copper by itself is 0. Silver is 0 by itself. Okay, copper can be +1 or +2, but we know the nitrate ion is always -1, and we have 2 of those, so this copper must be +2. Then we just did nitrate up here. Nitrate, it's always going to be +5. This oxygen's -2. Okay, this one down here. Oxygen's minus 2, hydrogen's plus 1. Okay, sulfate, SO4, the whole thing's minus 2. We know that oxygen's minus 2, that's minus 8. The sulfur must be plus 6. Lead is by itself, it's 0. Oxygen's minus 2. This is sulfate again, so you don't need to do it over. This is plus 6. Now, to figure out the lead when it's with something, because the lead can have multiple charges, well, it's PbSO4. And you know sulfate's minus 2, that must make the lead plus 2. Hydrogen's by itself or with itself, so that's 0. Okay, let's go down to this one right here. Magnesium is always plus 2. Okay, phosphate, PO4, if you know on an ion chart, that's always minus 3. If the oxygen's minus 2, which makes a total of minus 8, the phosphorus must be plus 5, because a plus 5 and a minus 8 gives you a net of minus 3. So that makes this a plus 5, oxygen's minus 2. Sodium's by itself, 0. Sodium's always plus 1, oxygen's minus 2. We just did the phosphate thing, it's plus 5. Magnesium is 0. Okay, that's how to assign oxidation numbers in a balanced chemical equation and just to do it in a compound. That's it.